afternoon, ladies and gentlemen. My name is Dr. John Belkowitz. I'm the Director of R&D at Intelligent Concrete, where we bring the magical world of concrete to you. Today, I have the privilege, nay, the pleasure of bringing another technical paper presentation to you. This happens to be one of my favorite papers ever written about, besides my own, obviously, but ever written about colloidal silica and concrete. It really, to me, it helped me understand what the impact was, really appreciate how size and surface area affected the hydration of cement, as well as, the tricalcium and dicalcium silicates. Just one of my favorite papers. Okay, so let's jump to the next slide. This again is, we're going to take the same approach that we did last time. We're going to look at why do we give a shit, why is this important. We'll see that in the abstract. In each one of these sections, we're going to identify the takeaways, and the big change that I did today was I actually included my takeaway notes. And from each section, I want you to be able to pull out whether or not this is good work or bad work. And what I love about this paper is that they really try to give you, the authors try to give you everything. And when I say everything, even when there was discrepancies in the work, they gave you a second method and why they thought they were discrepancies. Really just awesome. And then the last question is, now that we have these conclusions, where do we go from here? Next slide, please. Okay. All right, so here is the title, The Influence of Nanosilica on the Hydration of Portland Cement by G. Land and D. Stephen back in 2012, and this was published in the Journal of Material Science. Again, if you've never read it before and you're into colloidal silica and concrete cement hydration, this is something you really need to dive into. Next slide. Now, remember, because we're playing the game with a paper that is owned by somebody else, I can't give you everything. The only thing I can show you is the title, the authors, and the abstract. And what I'm going to do from here is not only give you those takeaway items, but I'm also going to show you some of the notes from this paper and give you an idea of how I highlight things, how I take notes. So yeah, let's take a look at this. So the abstract was just really beautiful. It dives right into, the purpose of the whole paper, citing what the impacts that they're looking for, this nucleation site for the kinetics of cement hydration for the development of calcium silicate hydrate. And because of this calcium silicate hydrate seeding that we see from nucleation, we have this accelerated cement hydration, and we go through different methods, calorimetry, X-ray diffraction, as well as, oh gosh, what was the last thing? And looking at the particle size distribution with two different methods. And ultimately what they're getting at here is that there is a surface size dependency on the positive impacts that we see throughout the paper. And really it's just that colloidal silica does, or nanosilica in this case, does amazing things for the hydrated cement matrix. All right, next slide. Okay, you can start seeing I'm starting to blur this out. Now here in the introduction, the authors do some great things. They really give us a great background. Why should we be reading this? What is the importance of all this information and how it ties in? And they start off, and I'm truncating a lot of this, they start off with defining what silica fume is. And defining silica fume is important because that's the easiest thing that we can compare to nanosilica. And after that, they get into what is nanosilica, and I think there was 4 or 5 different methods that they go into about how it is made, and which is really nice, but they focus on the sol gel method that they use. And then, of course, they're purchasing some nanosilica, 4 of the 9 nanosilicas from a distributor. They go into then pozzolanic reaction and then tied into, okay, now that we've given you all this, where is the nanosilica particle impact, and how do we think it's going to affect the kinetics of cement hydration? Next slide. Oh gosh, this is the second part of the introduction where there is so many takeaway items here. It's really hard to get them all in one of these vlogs here, one of these presentations. It starts out with this instantaneous pozzolanic reaction, the calcium silicate hydrate seeding, then it goes into the cement acceleration, but it's not just the description and the illustration that you see right here that is, blows you out of your mind, but it's also the references that they use from Bjornstrom to G to Thomas et al., and how they dive into, hey, we're not the guinea pigs. We're not the only one noticing these impacts or this effect on the hydrated cement matrix. There are other folks, and this is the detail that they get into that proves that what we're doing is warranted. And then they go into not only the filler effect, but pore water reduction, and leading it up to why all of this intro is so important, because now we've got to really highlight what this does, and we do that in the research significance in our next slide. And this research significance, it's short, it's a couple of sentences, but the significance is that nobody has recognized a correlation between silica surface area, Portland cement acceleration, and cement hydration. And funny enough, when I was reading this paper, I was diving into my research with the U.S. Army Corps. Like, I was just starting to get into the very same thing, but here I was focusing on the impact of nanosilica size and surface area on the on alkali silica ASR mitigation, and it really just a more focused approach than this. But that being said, again, just a wonderful paper, and the research significance again is highlighting that correlation between the surface area and these positive impacts, these positive effects that we're getting out of the use of nanosilica. All right, next slide. Okay, so we go from research significance to these methods and or materials and experimental methods, and I really like this. The big takeaway from this is that they do a great job in giving you not only the methods and the materials, to include the chemistry, the amounts, the weights, the percentages, so you can remake and recreate these test samples and these tests. And the three tests that they focus on here is particle size distribution or characterization, not only of the stuff that they're using, but also of the stuff that they bought. So there's 9 total suspensions, 4 of which were bought, 5 of which were created. And then from there, they get into calorimetry, which is the heat of hydration, not to be confused with the temperature of hydration. And that's going to be in milliwatts per gram. And then they dive into, and they do that because they want to look at the different phases of hydration, and looking at the heat of hydration, this calorimetry, especially when we look at isothermal, this change in energy. There's a lot of data that goes into the different peaks. The first peak being your calcium silicate hydrate development, then your second peak being your AFM development. So they give you one heck of an introduction into this. And not only that, but they go into what the expectations should be and why they think this change in the first peak is happening. And what I love about it is there's no sugarcoating anything. There's this one portion where they say that the first peak, the consumption of the tricalcium silicate, the formation of the calcium hydroxide calcium silicate hydrate phase, the hydration rate of calcium silicate hydration rate of tricalcium silicate, is significantly increased with increasing silica surface. I mean, just a really beautiful, bringing the results together. And they also discuss the limitations, but another portion which I really like is they go into that merging of the first and second peak and how that is related to the AFM phase, and how that is only possible because we see a sulfate reduction due to this accelerated set of reactions, as well as an absorption from the silica surface area. And really the last portion of this calorimetry, was that surface area is king. Oh, I absolutely love that. You know, something I forgot to mention was the particle size characterization. And they look at not only particle size, and that would be average, but they also look at surface area, and they even take a step into looking at these particles under a scanning electron microscope, and they tell you how to do it. And it really is just a beautiful paper because they even question their own methods, citing the discrepancies between the Sears and BET method when they're looking at surface area of these different nanosilica distribution. Just a great paper. Anytime there's a paper that questions its own methods or brings in a second method to really just give you a different look at a possible directional shift, or hey, if we use this different piece of equipment, we're going to notice maybe either a higher degree of resolution or a lower degree of resolution, but we're getting a second piece of information. So, you know, any type of paper like that, I'm always keen to read. But let's dive into the X-ray diffraction. And the X-ray diffraction is really quite nice. Oh, look at that. And I was supposed to jump. So I'm going to jump or switch slides earlier on. That's just a note for myself. So they go into the calorimetry. They go into the nanosilica size, particle characterization. They talk about the discrepancies. I'm going to my next slide. So that was, I'm sorry, I'm trying to write notes here. Slide 8, and then we got slide 9, and this is slide 10, results. We're going to call this results 1, and we're going to do this is results 2, and results 2 we're going to go at 12:00. Okay, so results 2, oh, that was the X-ray diffraction. So, you know, it's great that we're looking at calorimetry, but we have no, you know, other measurable method to look at the calcium silicate hydrate production because it is an amorphous like crystal, so we don't get those diffraction patterns like we would out of a repeating lattice structure. In comes X-ray diffraction, where we still can't see that amorphous calcium silicate hydrate, but we can see that crystalline calcium hydroxide, that Portlandite, and you know, through their research, you know, and they looked at it through a more qualifiable, you know, method. They found that there was an earlier rate of calcium hydroxide production, and at an earlier rate there was more of this calcium hydroxide production, signifying, and this was within a 24-hour period, if memory serves me correctly, or 12-hour period. It also shows that there is a higher degree of calcium silicate hydrate production because the two are synonymous. So what they did find is that this earlier production and this increased amount of calcium hydroxide was increased by with decreasing particle size. And if you haven't been paying attention to this point, you know, we're getting to the conclusions here where everything is tied together, and man, they've got this one part of the paper where it goes into, you know, and this is going back, this is the bing bang boom I've got on here before my conclusions, but I want to read this. A faster formation of Portlandite and a faster consumption of tricalcium silicate suggests that the formation of calcium silicate hydrate phase is accelerated as well. Since the calcium silicate hydrate phase is the main component for the strength development in cement, this acceleration should result in higher early strength of the hardened cement paste, which will be illustrated later on. This is almost like this should have been included in the conclusion. And I mean, that's maybe one thing that I would say was bad about this paper, that they should have done a better job of organizing it. But still, that being said, gosh, what a great paper. So the takeaway on the conclusions, what the authors were trying to get you to see is that the heat of hydration was increased with decreasing particle size and increasing nanosilica content. They had a greater earlier formation of calcium hydroxide and therefore calcium silicate hydrate development. Because of all this, as well as all the tests put together, they saw that there was an acceleration in this tricalcium silicate hydration, which was controlled by particle surface area. Now, this accelerated Portland cement or tricalcium silicate hydrate consumption is what they believed is caused by these calcium silicate hydrate seeds, and then an acceleration current confirmed, and all of this was confirmed by the experiments conducted. And there was an extra part which they kind of seemed to slide in at the end, which talked about this sulfate concentration that was reduced and controlled by surface area absorption. Again, it could have been worked into the paper. It kind of seemed like it was just jammed in at the last second. My last slide here for the acknowledgments is the, I just like this because, nobody's funding this. And that to me sets off some bells. There's no product supplier that's funding this, or at least wasn't annotated. There's no government agency. Nobody is putting a spin on this, or nobody is reviewing this and putting their 2 cents besides the authors. And the authors thank some other professors for doing some work, but really just seems like something that was funded by the university. And when you see something like that, that's just, that type of altruistic work is just beautiful. Okay, so excited to really hear your thoughts on this paper. Again, one of my favorites. Don't forget to throw your questions in there. We've got a lot of stuff coming down the chute, no pun intended, especially when it comes to colloidal silica. There's some great information on our YouTube channel, not only looking at the impact of colloidal silica hydrogels, a new version of this technology, but also looking at colloidal silica for making concrete more scalable and palatable, specifically looking at colloidal silica controlling segregation. And then we have another one on looking at colloidal silica for recycled concrete, making it more palatable, again, in the back of the ready-mix truck. And so we can use more of this recycled concrete aggregate. And then, of course, what I specialized in college was how to use colloidal silica for alkali silica reactivity mitigation. So thanks for joining us. Again, love this paper. Let us know your thoughts. Have a great day. Go concrete. Beat asphalt.